Okay, let's finish the 2-5 practice problems. Transformations of the functions. We finished all of the transformations. 2 practice problems from your My Math Lab have not necessarily, like there hasn't been one exactly like it in the notes. The concept's been taught. You should be able to put it together and answer it, but in case you're struggling, I was going to show you what they are. It's numbers 9 and 12. 9 looks really confusing when you read it, but if you will read it twice, you'll understand. It's simply saying, hey, here's function f, here's function g, match function g with a transformation of f, which means which one got transformed. Match function g with a transformation of f. Do you see that? It's saying transform f. How do you get f to become g? Look at the difference between the two. So how do you get x squared plus 3 to become x squared plus 1? What happened? You have to, it might help, if you're not comfortable with the numbers necessarily, think of the graph. This means what mother function? That's a quadratic that's where? Up 3. Okay, so f is 1, 2, 3. So f is up 3. That's f of x. Where's g? G is up 1. Right? Okay, and what does it say? It says match the function g with a transformation of f. They're saying, how did you go from f to g? What happened in the graph? It goes down 2. So you come over here and you say to yourself, if this had minus 2 after function f, like function f is right here, if I had minus 2, would I end up with function g? Alright, so which answer choice is that? B. That is B. The difference is right here, it's saying, hey, add 2 to function f. Well, that wouldn't work. That would make f go higher, right? This is saying, take function f, reflect it over the x-axis, and vertically stretch it. That is not at all where g is. This is saying, take function f and go what direction with it? Left 2. That's not what g is doing. This is saying, take function, let me go here. This is saying, take function f, reflect it over the, remember, it's anything right next to the x. Axis, the x value is backwards. So you see it next to the x, it's actually reflecting over the y. And you see a 2, that'd make you think a stretch. It's actually a horizontal shrink. This would make it go where? Right 2. So that's why this is the answer. Because this would take function f, and it would bring it down 2, and it would land in place of function g. Does that make sense? So that one was a little tricky because of the way the question is worded, but it's just one adjustment to a function, and it's asking you what adjustment needs to be made. If you need a visual, just graph it, sketch a graph. This one right here, write an equation for the function that has the shape of y equals the absolute value of x, but reflected across the y-axis, shifted right 2 and up 5. Okay, so right 2 and up 5 should be the ones you prefer. When it's reflecting over the y-axis, that means what is going to go in the equation? Any reflection means there's a negative. Now you have to know, you have to fill out the form. Yeah. Now you have to know where to put the negative. If it was reflecting over the x-axis, that's what you already know from prior math classes. The negative just goes all the way in the front. If it's reflecting over the y-axis, it's going to go where? It's going to go on the inside with the x, right? Like D, that's it, like D up here, similar to that. Okay, so now you have to write it. So we have f of x equals, what's the mother function? Square root. Okay, so we have the square root, and they want you to put the negative in front of a set of parentheses. This is what I didn't do in mine because I don't do this normally. I don't do the parentheses, but they prefer that. They want the negative to go in a set of parentheses if there's any horizontal shift. What's the horizontal shift? Right 2. Right 2 inside parentheses would look like minus 2. And then at the very end it would be what? Plus 5 on the outside of the radical. Okay? So that question does come up, and they are expecting the negative to be in the radical, but in front of parentheses, and then you do the horizontal shift in the parentheses. Okay. All right, let's keep practicing. All right, we did this one, which was the vertical stretch by 2. Then we did that one, vertical shrink by 1/2. Now we're at this one. Now, in the My Math Lab homework, it's a widget. And it's not a piecewise function, but it's a widget where the first button you have to pick is what type of mother function it is. Then you have to plot the mother function by clicking where the mother function starts. And I'm pretty sure they all, that's where this page would be helpful. Yeah, every single one of them starts at 0, 0. The linears at 0, the quadratics at 0, 0, the square root mother functions at 0, 0. Every single one of them is has an anchor point at the origin. So that's what you have to click in the My Math Lab. And when you click that, it will by default project the mother function graph. Then you have sliders. It'll say vertical shift, horizontal shift, vertical stretch or shrink, horizontal stretch or shrink, I think. Then there's buttons, and it's reflect over the X, reflect over the Y. You just check those. You just sit there and play with it for a second, and you'll see whatever you do, sliding it or checking a box, it will already change the graph. So you can see the visual as you're adjusting it, okay? But if the widget's throwing you off, then call me over to you and I'll help you, because I don't want you to get it wrong because of the widget. I'd rather, if you got it wrong, it's because you didn't know the math, not because the My Math Lab widget screwed you over, you know what I mean? So we need to make sure you practice that in class today. All right, so looking at this one, we're taking this piecewise function, and what are we doing to it here? What's the difference? We're multiplying something by 2. That's what I see. Where is the 2, though? It's next to the x, which means this is inside brackets, or in this case, parentheses. So it's Bass backwards, right? Or counterintuitive. I wrote that one because it's shorter. But this is backwards from what you would see. So I see times 2, which would make me think a stretch. So it's actually a shrink. It's horizontal. You know that because it's within the bars. The 2 is within the bars. So it's a horizontal shrink by 2. Now, how do we actually get it? Okay, look over here at the difference. Where was it? This one. Where was the 2 here? It was in the very front. And all we had to do was multiply, because f of x stands for y. All we had to do was multiply the y's by 2, and that's how you got that vertical stretch, right? Well, if I'm dealing with a horizontal shrink, you following? Then what is changing? Is the x changing or the y changing? Which one? It's the x changing. So we're going to divide the x's by 2. Why did I say divide? Because it's backwards from what it looks like. I see times 2. To actually plot it, I'm going to divide by 2. So we're going to divide the x's by 2. Now, you'll notice you didn't really have to do this for the My Math Lab homework, but it's a good practice for you to understand how these graphs transform. So I'm focusing on the x's. So negative 5 divided by 2 would be negative 2.5. 0. Right? Negative 2 divided by 2 would be negative 1. Still at 2, though. Does the origin change? 2 divided by 2 would be 1. Stay at negative 4. And 4 divided by 2, oh my. 4 divided by 2 would be 2. Remember me saying yesterday that graphically a horizontal shrink will look like a vertical stretch, but algebraically the function totally different. The placement of the 2 is the difference. But graphically they're the same. That's why I would never give you a graph and say, tell me what happened here with a stretch or a shrink, because you can't. You would have to, unless I said, tell me all the cases. But I don't think that was in the homework. Right? It's not in the My Math Lab. The My Math Lab is the precursor to the test. The test comes from questions in My Math Lab homeworks. Yeah, they're just going to change the numbers. All right, look at the next one. It's inside the bars. Hope y'all are following this thought process. The number is inside the bars, which means it's something horizontal, which means hold up. Think of the big H that I made y'all draw. Hold up, wait a minute. Everything is the opposite of what it seems. So let's make a note. You can just write backwards if you want, or backwards, or counterintuitive. It's up to y'all. All right. What is it, first of all? It's a number in front of the x, which means it's a stretch or a shrink. I see a half, which means to me would be shrink, but it's in the bars, so it's a stretch. So this is a horizontal stretch. By 1/2. Now, you might be wondering, how in the world is that going to stretch out if I have a half? Okay, well, go back to this one. When we had a horizontal shrink by 2, we did what with the x's? We divided the x's by 2. If I'm going to divide the x's by 1/2, dot, 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 then what am I actually doing? I'm actually multiplying by 2 because of that key change flip. You never divide fractions. Now, it's okay to tell me that you're dividing by 1/2, but when you go to actually do it, you're going to want to just multiply by 2 because of key change flip. Like, you would keep the number as is, you would change it to multiplication, you would flip the 2 over 1, or the 1 over 2, and it would become 2 over 1. So I'm going to put dot, 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 big arrow, which means multiply by 2. Okay, so we're multiplying the x values by 2. So we got negative 10, 0, negative 4, 2, 0, 0, 4, negative 4, and 8, 0. All right, you try the next one. How many things are happening here? There's 2 things happening. What's one of them? You've got a horizontal stretch, and you have, anytime there's a negative, like in the front of either the x or in the front of the function, it means a reflection. Just remember, the very front of the function, the one that you've known since Algebra 1, that's reflecting over the x-axis. When it's right next to the x, it's backwards, so it's actually going over the y-axis. So we have reflect over y-axis, and we have horizontal. I see a half, that makes me think shrink, so it's actually a stretch by a half. So this is the same type of problem as the last one. When I go to divide the x's by negative 1/2, I'm actually going to what? Be doing what? I'm actually going to multiply by negative 2. Alright, so negative 5 times negative 2 is positive 10, 0. Negative 2 times negative 2 is positive 4, 2. 0, 0 doesn't move. 2 times negative 2 is negative 4. Is that cookies? Is it cookies? Yeah. Did I put it in the wrong spot? So this would be negative 4, negative 4. Multiply the x's by negative 2, right? You have 2. Oh, that's this one. So this is times negative 2. Oh, okay. You see it now? Because remember, it's going over the y-axis. So this is actually going to go over there, and now we're going to have a curve down here. So this would be -4, and then this would be -8. Yeah, I was going right? Still rich, but they're not as bad. As soon as you finish the chocolate ones, you're like, ugh, I should have eaten that. They are so good. Why did we do that to ourselves? I wish that was fun. Alright, now let's put it all together. Look at this one right here. This is summarizing everything, okay? Here are your bars that I was telling you for like anything to do with horizontal, whether it's a shift or a horizontal stretch or shrink or reflection. There's one word on here that we've not used. I don't use the word compress, I say shrink. So everywhere you see compression, if you want to, you can go in and write shrink. Or you can leave it, I mean, y'all know what compress means, but you're not going to hear me say compression. I pulled this from another website because I liked how it organized everything. So the placement of A. A is in the very front, which is helpful because A is the front of the alphabet. So the thing in the very, very, very front, remember if A is a positive number, this just means positive, it's stretching. If it's negative, it's shrinking. Or negative. If it's less than 1, I should say. If it's greater than 1, what was that? Big energy? Isn't that what it said? Rubber band? Remember this part? This was the rubber band demonstration that I showed you. If it's less than 1, it's a fraction of the energy. If it's negative, it's flipping over the x-axis. The number, if the number is bigger than 1, it's stretch. If it's less than 1, it's shrink. The placement of the number, if the number is in the very, very, very front, it's vertical. If it's inside any bars, brackets, radical, cubic, quadratic, absolute value, those are all the possible scenarios. If it's inside the bars, you think of the big H that we drew and hold up, that means horizontal. The H for horizontal, the H for hold up, wait a minute, think about it. The H for it's inside bars. B and C are inside bars. Those are the only ones, I'm trying to draw an asterisk, Those are the only ones that you have to stop and think. You have to be careful on B and C. It is going to be counterintuitive. And if B is negative, it's flipping over the y-axis. And that's it. So at this point, go to your 2-5 homework, be finishing it, and go ahead and practice. I was going to go into the, give me just a minute, let me see if I can do it very quickly. I was going to go into the practice and delete the questions that are not on the test so that you would only be practicing, because there's like, normally I wouldn't do that, but instead of just 2 or 3 extra questions, there's like 10 extra questions. And it just makes it more stressful. Oh, does anyone else have their signed report card?
I do.
Okay, turn that in.